Good afternoon, everyone, and thank you for joining us here on Flight Day 23 of the Artemis I mission. We're here today to talk about Splashdown coming up on December 11th. And to join us, I have Mike Seraphin, Artemis I Mission Manager, Judd Freeling, Artemis I Ascent and Entry Flight Director, Jim Geffrey, Orion Vehicle Integration Manager, and Melissa Jones on the phone, the Landing and Recovery Director. We're going to allow our participants here to provide some opening remarks, and then we'll get into the question and answer session. A reminder, if you're on the phone, to please press *1 to raise your hand and ask a question, and *2 if your question has been asked and you need to withdraw it. But first, we will start with those opening remarks, and I'll toss it over to you, Mike.
All right. Thank you, Leah. Well, good afternoon, and thank you for continuing to follow our program in the Artemis I mission. We are on Flight Day 23 of our 26-day uncrewed flight test. The mission continues to proceed well and along the planned mission profile, and we are setting up for Earth reentry and splashdown and recovery of the Orion capsule following a skip reentry on December the 11th. At present, we are on track to have a fully successful mission with some bonus objectives that we've achieved along the way. And on entry day, we will realize our priority 1 objective, which is to demonstrate the vehicle at lunar reentry conditions, as well as our priority 3 objective, which is to retrieve the spacecraft. Since I was here to speak with you last, the mission management team has met daily, and we will meet again on Friday and Saturday. On Monday, December the 5th, I was here last, and we met again on Tuesday, December the 6th for an hour and a half. We did get an outbrief of the anomaly resolution team associated with the power conditioning and distribution unit, funnies that we've been seeing associated with the latching current limiters. We did approve some additional testing of the spacecraft to gather additional data on the anomalous behavior that we've seen, and that testing has been completed, and we actually may have a additional test in the coming days. We also saw some degraded behavior on Tuesday associated with one of the phased array antennas, which is used for communications and tracking of the spacecraft back to Earth through the Deep Space Network on the crew module adapter, specifically phased array antenna number 1. The antenna is performing, but it has low performance and is causing some periodic comm dropouts when we're on that antenna. On Wednesday, December the 7th, we met for an hour and 15 minutes roughly. We talked again through the power conditioning and distribution unit test results that were approved on the prior day, as well as the anomaly resolution team outbrief, and continued to understand what our engineering teams were finding, as well as our operations teams were finding through the additional troubleshooting on the spacecraft's power system. In parallel with that, our recovery teams deployed from Naval Base San Diego on Wednesday, December the 7th, and they're currently at sea, and you'll hear that from our recovery director, Melissa Jones, here shortly. Today, we met for right at about an hour, and it was our pick'em day. We decided our landing site, and our entry flight director, Judd Freeling, and our recovery director, Melissa Jones, came in with a recommendation and of consideration associated with the landing site selection as a cold front that is moving into the Southern California area and off the coast in the Pacific. So that was factored into the landing site selection. Primary factors associated with landing site selection: we have spacecraft design limits, we have recovery operations safety, and then we have test objectives associated with imagery, associated with some of the jettisoned items and parachute deploy sequence. So those were factored into the decision that you'll hear more about when Judd speaks. As we start wrapping up the mission, I want to thank the team and specifically the mission management team. When you look at the program that we have, which is a Space Launch System rocket managed out of the Marshall Space Flight Center, our Exploration Ground Systems team managed out of the Kennedy Space Center for both the launch operations, the vehicle processing prior to flight, and then the recovery operations. And then you look at the activities out of the Johnson Space Center with the Orion spacecraft team and our flight operations team. There's no one center, and there's no one program and no one person. It is a team effort. And we have a diverse team of skills. We have system designers, we have flight programs, we have engineering technical authorities, we have safety experts, and as well as our industry and international partners involved. And if we could pull up a couple of photos, these are just a few shots through the course of our mission management team meetings. This one occurred during the return powered flyby, and we were, you can see in the screen in the background, we were about to witness the Earthrise together as a team. We had it live streamed in, and we paused for about a minute there. The room was just absolutely silent as we absorbed the Earthrise moment. It was my Earthrise too, as part of the Artemis generation. I think I was 4 months old when Apollo 17 left the moon. So that was my Earthrise moment as well. There we are. That's the Secretariat, Joe Williams, sitting next to me in the course of the meeting, and some of our cross-program systems integration team and our engineering technical authority sitting in the background. If we go to the next photo, this is Zeb Scoville, one of the MMT members from Flight Operations Directorate, weighing in on a conversation. If we go to the next photo, this is Chris Edelin, who you've seen come talk to you. He's the head of our Orion engineering team in the mission evaluation room. And to the right of the screen there is our lead flight director, Rick LeBrode, and then we have the NASA Engineering and Safety Center lead, Ben Himany, in there. So it is a diverse team. Again, it represents multiple NASA centers. We have our international partners. We have our industry partners all on that team, and it was an honor and a privilege to lead that team through a number of pre-planned decision gates, as well as some of the issues that we had to work through. In parallel with all that, we continue to prepare for Artemis II and later missions. We have production of the core stage ongoing at the Michoud Assembly Facility. We have boosters that have been prepared at the Promontory facility in Utah. We have our upcoming Orion spacecraft in preparation at the Operations and Checkout Facility at the Kennedy Space Center, as well as later service modules past Artemis II in production in Europe with our European Space Agency partners. But we're also getting the mobile launcher ready. If we could roll the video from the rollback activities that are occurring presently. The mobile launcher that Artemis I was launched from is headed back from the launch pad to the vehicle assembly building. If we could roll that video, please. Here is the mobile launcher moving down the crawlerway. When you can see the clean pad concept in the background, and our engineers walking along just to check the health of the crawler itself. And there is a lovely vacant mobile launcher. The 322-foot tall Artemis vehicle is missing, and we're going to take it back to the vehicle assembly building, and it should arrive there late today. We'll park it outside and then bring it inside the vehicle assembly building to complete some of the inspection activities. But the mobile launcher is on track to be ready for Artemis II. So all that said, we are wrapping this mission up. We are not letting our guard down. We have some hard stuff ahead of us. We have dynamic flight phases, and we are encouraged by the progress that we've made and the path that we're on. So with that, I'll pass it back to you, Leah.
Thank you, Mike. And I'll turn it over to Judd Freeling, ASCEN Entry Flight Director for Artemis I.
Thanks, Leah. Let's see, as Mike said, we're on the home stretch, but we're not quite there, so we still have some critical events that we're looking to perform. Tomorrow we'll be checking out the crew module reaction control system, so we'll pressurize that system by firing some pyrotechnic valves to make sure everything is healthy in that system for use when we come in for entry. And then Saturday we have our fifth return trajectory correction burn, followed by then, of course, Sunday we've got our sixth return trajectory burn, followed by the entry and entry interface at 11:20 a.m. Central Time. Let's see. Let's put up the graphic there. So this is the track that Orion will be following. At the very bottom of the chart there, you'll see the entry interface. That's again at 400,000 feet. Go all the way through skip apogee, which you can see is kind of in the middle of that chart, to our landing site. Now, as Mike mentioned, our landing site would normally be in the San Diego area. We also have a northern weather alternate site that we could have chosen that's just north of our nominal site. But both of those are forecast to be no-go for weather constraints due to a cold front that will be moving in right around the time that we have Splashdown. So, as a consequence, we've decided to move uprange of this track by 300 nautical miles. So if that line scooted downward to the south by 300 nautical miles, we'd be landing right off the Guadalupe Island off the coast of Baja. So that's 300 nautical miles uprange. If you go to the next 3D version, you can kind of see what that looks like from the side view. With the skip entry, it'll show you the long track, the long arc that we'll take along the the Earth's surface. You can barely make out that we're doing that skip apogee, or during the skip and then apogee. It all looks really tiny compared to the size of the Earth. But that will end up a little short of what that landing site says, again, at that alternate weather site that will be due south. Our nominal entry range for this would have been 3,500 nautical miles. Of course, you take 300 miles off that, it will be about 3,200 nautical miles, well within our capability and well within our test objectives. Let's see, next slide is a little close-up on what that skip entry sequence looks like. About 20 minutes before we hit entry interface, we will separate the crew module from the service module. All of that, the power and propulsion system from the service module will no longer need, and that will burn up in the Pacific. We'll perform a raise maneuver in front of the crew module, and that shallows out our trajectory with respect to the service module, so it gives us a little bit more lift in our trajectory. We'll proceed down through the bottom of that arc there, and then start modulating our lift vector back upwards so that we do that script profile, and also modulate our energies such that we target that weather and alternate site that I spoke about previously. We'll come in later on in the trajectory. We'll deploy the forward bay cover, which will expose the drogues and the chutes. We'll deploy the drogues and chutes, and of course then splash down. The next slide shows a little bit more detail of those chute deploy sequences. So you can see the forward bay cover there. Around 35,000 feet or so starts to deploy. At least the chutes come out to deploy that, and then we'll start on our drogues around that 24,000 feet, all the way to about 6,000 or so, 6,800 feet or so when we deploy or jettison the drogues, and then we'll deploy the mains about 5,300 feet or so. All the way down to 1,500 feet, and at that point we will actually start controlling the roll of the capsule so that we hit the water at the same angle, at the proper angle into the wind, right? So we have the least amount of load on the structure. All right, let's see. I think that's the last slide I have to go there. As I mentioned, when we splash down, we will actually be in the water for about 2 hours. We have some flight test objectives to complete, and that 2-hour mark, it's essentially a soak back flight test objective. We're testing all of the heat that has come and been generated on the capsule. We want to make sure that we characterize how that's going to affect the interior of the capsule, and I think Jim will probably talk a little bit more about that in his presentation. But essentially, that 2 hours is for that objective, and once we finish with that objective, we'll hand over the capsule to Melissa Jones, and then she'll start her recovery process. So with that, Leah, back over to you.
Thank you, Judd, and I will turn it over to Jim Geffrey.
Thank you, Leah. The Artemis I mission continues to go very well. We've collected an immense amount of data characterizing system performance from the power system, the propulsion, GNC, and so far the flight control team has downlinked over 140 gigabytes of engineering and imagery data that the team is already analyzing to help not only understand the performance on Artemis I, but play forward for all subsequent missions. Our propulsion system has performed very well. We're on target to hit our very narrow entry corridor on Sunday, and so we're on target to achieve our landing site. But as Mike said earlier, our top Artemis I mission priority is still ahead of us, which is to demonstrate the guidance system of Orion, as well as the heat shield performance as we return from 25,000 miles per hour returning from the moon. We collected some really great data as we flew by the moon a couple days ago. And if we could bring up the first imagery, I wanted to show this one. This image was taken by Orion's onboard optical navigation system. This camera is used as a secondary means to identify where Orion is in the solar system by taking images of the moon and Earth. And we were able to capture a really great image here, both the Apollo 14 and 15 landing sites. You could see the Fra Maura site of Apollo 14, as well as Hadley for Apollo 15, with the Copernicus crater in the lower middle portion of the view. Apollo 12 is just off the frame. This, for me, is a great reminder that here we are on the 50th anniversary of Apollo 17. We're continuing the exploration adventure started by Apollo, and Artemis I is continuing that. The next chart I want to show is the skip entry sequence. As Judd described earlier, this is a novel technique for a human exploration spacecraft that allows the vehicle to fly all the way back off the west coast of North America. So a few interesting things about this trajectory is, first of all, it's about 20 minutes from entry interface to splashdown. The astronauts on board for Artemis II would experience around 4 Gs at the peak acceleration point. That's similar to what astronauts experience returning from low Earth orbit, so well within the human capability for a deconditioned crew member. Once we splash down, we're also going to collect the additional data that Judd mentioned. We'll see how the heat soaks back into the crew module and how that affects the temperature inside, and make sure that it stays within crew limits. So we're very excited here on Sunday, but we still have the top Artemis I mission priority ahead of us, as well as demonstrating the recovery of the capsule. Thank you.
Thanks, Jim. And joining us on the phone is Melissa Jones, Landing and Recovery Director.
Good afternoon. I'm excited to be joining you guys from the USS Portland. As you heard, we've decided on our landing site for Artemis I mission, and the ship is making its way to that location now. On board the ship, we are working with our Navy counterparts to prepare to recover the Orion once it splashes down on December 11th. And our plan for that is to get to the landing site 24 hours ahead of splashdown, where we will start launching weather balloons to gather data for reentry. We man the control center about 5 hours before splashdown. And prior to splashdown, the Navy will deploy small boats and launch helicopters as we are monitoring intercommunications from the MCC to ensure that those local assets are safe as hardware falls out of the sky, the jettison hardware that comes off the capsule. Once it splashes down, while Judd is monitoring the DFTO that he mentioned before for thermal soakback and the vehicle's still powered, we're doing a couple of different things that we're focusing on. We're getting ready to recover the jettison hardware, trying to get to it before it sinks. We're also performing an Angel beacon test, which is the beacon that will be on the astronaut suit, and comparing that to the crew module beacon signature to make sure that they're discernible from the satellite. And Goddard Space Flight Center folks are on board to do that. And we're doing a hazard assessment of the capsule from the helicopters to make sure that everything's nominal and there's nothing visible prior to bringing the capsule into the ship. Once we're done with all of those assessments and the DFTO is complete and power down happens and Judd formally hands the vehicle over to the local team, we'll do a hazard assessment. The divers will as they approach the capsule. And then we will do imagery and data gathering underwater and above water to ensure that the CM condition is documented post-splashdown prior to bringing it into the well deck of the ship. Once that's complete, the ship will approach, attach lines, and we will put the crew module in the well deck and fit it down into a cradle. Once the spacecraft is secured, engineers will begin analyzing the capsule and taking additional pictures. And at that time, we will start our transit back to port, which will be delayed a day due to the fact that we had to transit 300 nautical miles south of the weather alternate. This team has done a lot of training and practicing to bring us to this point, and it's an honor to be leading the team that brings Orion home.
Thank you, Melissa. We'll now move into the question and answer portion of today's briefing. It's a reminder, if you're on the phone, please press *1 to raise your hand to ask a question, and *2 if your question has been asked and answered. We're going to start here in the room. We'll start on this side.
Hi, Eric Berger with Ars Technica. Question about the skip entry. Just wondering from a overall mission standpoint, maybe a question for Mike, I'm not sure. Why this architecture, why this return profile was chosen for the Artemis missions, and how important it is to demonstrate it on this first mission for future crew missions?
Yeah, Eric, thank you for the question. I'll ask Jim for some help on this one, since he's been with the Orion program longer than I have. But you know, fundamentally, the skip reentry has a lower G profile than a direct or ballistic reentry, and the amount of deceleration that you put not only on the spacecraft but the passengers, the astronauts riding on board, was a key consideration. Jim, if you have any other thoughts, you were part of some of the original trades.
Yeah. Yeah, thanks, Mike. That's a great question. Another important aspect of the skip entry is it allows us to target a single landing site regardless of when you launch during the mission. So by varying what we call the azimuth, the direction at which the crew module flies back to the target, we're always able to narrow our operations to that landing zone, which Judd described earlier. If you compare that back to the Apollo missions, where the U.S. Navy was deployed all over the Pacific Ocean, this helps both from an operational and efficiency standpoint by always targeting the same spot.
Does it increase risk, the sort of the additional maneuvering, or is that just wondering, like, kind of coming down, going up, going down? Dumb question, but it seems like it makes it a little bit more complex.
Yeah, I mean, fundamentally, you got to take all the energy out of the spacecraft that was put into it earlier. This is just one way of doing it. Again, skip reentry as opposed to the direct or ballistic down mode. It's just a different profile in terms of heat rate and heat impulse that comes out of the vehicle. But all of that needs to come out. The heat shield needs to perform regardless of which profile we fly, and this vehicle is prepared to fly any of those. In terms of risk, you know, there are roll maneuvers required to execute this. The vehicle gets aerodynamic capture. It's stable once it gets aerodynamic capture. The roll is simply just changing the lift vector. So in terms of risk, I would say it's a marginal to no increase in risk.
I would say marginally no. I mean, we did the same kind of thing on shuttle where we do roll reversals to target specific points, right? So the avionics, modern avionics for guidance are really accurate from that perspective.
Okay. Next question in the room.
Gina Sinceri, ABC News. This is for Judd. So you've got a range up and down the coast of California. You could go north or south, and tell me why south. I'm a little confused exactly where you're coming down. Could you explain that to me?
Sure. Thanks, Gina. So if you throw up that slide again that shows the 2D map, I can explain it to you. So when we deorbited from the moon on RPF, we set our entry interface target to that point that's at the bottom of the screen, right? So and so therefore, the only possible way we can go is either continue on up that trajectory as far as our energy allows, or we can go shorter. We can dissipate more energy and land shorter, right? So by modulating our lift vector with this skip entry profile, we have the full range. We can go all the way to San Diego and even a little bit further by essentially lofting more and going a little bit further, or we can modulate our lift vector thus that we kind of bury it in the earth and we go straight down, right? So those are our only possibilities. We don't have a lot of cross-range capability. We can't go left to right significantly. We use that capability left to right to really modulate our downrange capabilities. Does that answer your question? Sure.
All right, our next question in the room.
Thank you. Mark Carreau with Aviation Week and Space Technology. I think this is for Mike. In the previous two briefings, you've talked about adding some objectives that you could do because of the performance and the success of the mission along the way. I wonder if anything at this point has sort of jumped out and just sort of struck you as, boy, this was a good thing we had the opportunity to do it. I mean, there's probably several, but I just wonder if there's anything that just really rises.
Mark, thank you for the question. The one that kind of pops to my mind was the thermal characterization of the vehicle. We have essentially a 20 degree by 20 degree box that the vehicle wants to fly about tail to sun. And the team asked to fly kind of the edges of the box to see, do certain components on the vehicle get hot? We know we need to protect star trackers. We know that cameras can get hot that are mounted externally. And overall, the vehicles perform very well in terms of thermal characterization. And when we set up for the flight initially, I think we were looking at like a 2 degree attitude box within that 20 degree envelope that we said that the vehicle was designed and certified to fly. And now that we've explored that, it shows that we've got a lot more flexibility operationally. And that becomes more important when you start looking at downstream missions for things like rendezvous and proximity operations, where you may have to, if you're the chaser vehicle and you're approaching a target vehicle and you have to be in that out of that attitude for an extended period of time, it affords some flexibility operationally. And also for mated operations, if the vehicle that you're mated with or docked with, for example, on future flights with Gateway, has an issue that you want to help them out, it tells us that we've got a little flexibility there as well. So the thermal characterization and going after that, we had additional propellant to do it. We are well above the margins required to complete the normal mission. We've got over a ton of extra propellant on the vehicle right now to do that. So this was just a wise use of understanding our models and how the flight environment matched the modeling, and it helped us buy down some of those uncertainties. So that was the one that comes to mind for me.
Okay, we'll now move to questions on the phone bridge. A reminder, if you're on the phone, please state your name and affiliation and to whom your question is directed. First, we'll start with Robert Perlman and Collect Space.
Hi. This question is probably for all four panel members because it's somewhat subjective. But to try to put this, what we're going into here with the reentry, into some historical context, it was mentioned we're on the Apollo 17 anniversary. Happens to be that when we land on Sunday back on Earth, it'll be the 50th anniversary of the landing on the moon for Apollo 17. How would you categorize which is the bigger challenge, bringing back a new spacecraft to Earth for the first time, or landing on the moon for the sixth time, but in a new place that you hadn't been before?
Yeah, I'll start with that one, and we'll work our way down. Robert, this is my 65th mission supporting human space flight, and flight testing is my jam. I love flight testing, and I would say that the first time you do anything is harder than a repeat, but that is not accounting for new changes or new objectives or harder objectives that occur on later flights. So it's a difficult question to answer, because I know Apollo 17 was one of the farthest off the equator for the moon relative to the Apollo landing sites, and the farther you get away from the equator for the Apollo architecture, that made that a much more difficult mission to accomplish. So, just in general, I would say firsts are harder because you almost don't know what you don't know. But as you get more and more complex missions, like Apollo 17 was, that becomes a very challenging question to answer. I don't know, Judd, what your thoughts are.
So the way I'd answer that question is as an operator, we've practiced these same kind of operations over and over again in simulations, right? So by the time we get to actually performing the actual operation, we've done it so many times, we practice it in failure scenarios, it in many respects feels like we've done this many times before. So what I would say from my perspective, the way we mitigate any first-time actions is we practice over and over again, such that we make sure that we know in certain failure scenarios what we're going to do. We have that outlined in our mission rules and procedures, and so we expect the unexpected in many respects.
Yeah, I think this is a good reminder that Artemis I is a test flight. No matter how good or how many design analyses you do, tests you do on Earth-based facilities, there's no perfect replication for flying in space. We've already demonstrated there are some differences between the ground and flight, and we've used the onboard instrumentation to collect data, or downlink that to Earth, and we're learning from the mission. So again, it is a test flight, and doing it for the first time, you learn things that you just didn't anticipate.
All right.
Melissa, do you want to take a crack at that one as well?
And we were wondering, Melissa, if you would want to speak to that as well. Okay, we'll move on to the next question with Chris Davenport and the Washington Post.
Hi, thanks so much. Can you hear me?
Yes, we can hear you. Yes.
Okay, great. I guess this is for Mike or Judd. There's been a lot of talk about testing of the heat shield coming from the lunar reentry trajectory, but less, I feel, about the parachutes, and I'm just wondering how you're feeling about them, if you have any concerns, or if you think you retired the risk associated with the chutes during the EFT-1 mission. Thanks.
Chris, thank you for the question. I will say that parachutes, in terms of overall mission risk, it is on the top risk drivers in what we call the Pareto chart that shows like our top 25 risk drivers. So there is definitely some risks there associated with the parachute deployment and subsonic descent and deceleration of the vehicle. That said, the program, and Jim can speak to the specifics, the program put in considerable effort to develop, test, and certify the parachute system, specifically at the Yuma Proving Grounds with our partners out at Yuma to buy down that risk. And I feel like that risk has been well characterized. They did high altitude, the normal altitude, low altitude deploys, single parachute failure cases, and all of that has been well characterized. We understand that there is some residual risk there, but that said, I think we understand it. I don't know, Jim, if you have anything to add to that one.
I think that's a great answer and a great question. As you described, the Orion program did a very robust series of tests out at Yuma. 47 total drop tests in different configurations, ranging from demonstration articles up to full-scale complete sequence tests. And also, as mentioned, the EFT-1 was a flight demonstration returning from space, and the parachute system operated perfectly. So while there remains risk in parachute systems at all times, I think we've characterized the performance and the risks very well and are prepared for for anything that may come.
All right, our next question is from Christopher Mick with the Hudson Star Observer.
Hello, Christopher Mick, Hudson Star Observer. Thank you for taking my question. I believe this would be for Mike. I wanted to ask if there's any kind of anticipated timeline on when the data recorders on board the capsule, the dosimeters and whatnot, when that information might be made public.
Christopher, thank you for the question. In terms of the dosimeter data being made public, I do not have a date on that. I know for a fact that we need to get the spacecraft back to the Kennedy Space Center, which will happen in late December, and then we'll start removing the dosimeters and the payloads and a whole host of things, including the mannequins, the seed accelerometers, and a number of biometric and other microphone data and other things that are in the cabin. In terms of a specific release of that, I think we would have to follow up with you on that one.
Okay. Our next question is from Mike Wall with space.com.
Thank you all for doing this. Just a quick question. I mean, it looks like during the reentry, Orion's going to be pretty far off the west coast of both South America and North America. But is there any chance any folks along those coasts might be able to see it in the sky as it's coming back in? And just a quick question too about what's going to happen after splashdown. Could you just give us a quick rundown of kind of when it's going to get back to shore? I mean, what the plans are, just sort of after recovery in sort of broad strokes.
Sure. Thanks, Mike. I'll take that one. As far as is anybody going to be able to see that off Baja? There's always a chance, but we're pretty far off the coast there, so I doubt it unless you're out in a boat, 100 miles offshore or so. But as far as what's going to happen after we enter, so as I mentioned, once we splash down, we'll stay in a powered configuration for 2 hours for that soakback test, and also, as Melissa mentioned, the Angel beacon tests as well. Once we power down the vehicle, we'll hand that over to Melissa and her team. And if she's not online anymore, I probably can talk a little bit about what she does. So she will then, it'll take them about 4 to 6 hours or so to get the capsule back in the well deck. And then once those operations are complete, they'll head back towards San Diego, and that'll again take them about a day or so to get back into port. And then they have a timeline to get that back to Kennedy, and I think that's around a couple of weeks or so.
Yeah, and Mike, the only thing to add is it will be daylight during the reentry, so seeing a reentry vehicle during the daylight is definitely more difficult than at night. You're more likely to hear the sonic boom as the vehicle approaches than anything.
Okay, and just a note for anyone preparing to ask a question, we do not have contact with Melissa Jones right now. She is virtual and on the ship preparing for splashdown, so we're working to regain that signal, but in the meantime, you'll have these guys. So next question we have is from Leo Enright with Irish TV.
Thanks very much, Julia. I was wondering, how are you assessing the risk of a collision with another object on the way in at lunar return speeds? It was really striking that you had 36 COLA cutouts during a 2-hour launch window. So I'm just wondering, how big a worry is it coming back in that, something could happen? And of course, that problem, there was a launch just 10 minutes ago out of Cape Canaveral of another constellation. So this problem is going to increase for human missions. I'm just wondering how you assess it.
Yeah, thanks for the question. So we do assess that, right? So we have the current state of the vehicle and what its path is going to be along the Earth's surface. We also work in concert with U.S. Stratcom to assess. They have a catalog of all of the objects that are in low Earth orbit, and so we have them doing a screening against our trajectory versus all of the other ones. The good news is there's only two objects that we are tracking right now as we're coming into entry interface as being anything that's anywhere near the box, and those probability of collisions are essentially zero. We are moving essentially perpendicular to all the rest of those objects, and we're traveling extremely fast. As far as why we had so many on launch day, well, we're starting from zero speed, and we're starting to go through all of that, those objects in space. And so, depending on when we launch, we make sure that we have a low probability of hitting all of those. Just because we had these COLA cutouts doesn't mean that there are necessarily a lot of objects that we're going to hit. It just happened to line up with those the times that we were planning to launch, right? So I would say that's also low risk. It's actually quite a big space out there.
Next question is from Jeff Faust with Space News.
Good afternoon. Question for Mike, just sort of an update from some of the earlier briefings. Where are you in terms of percentage complete on objectives and percentage still in progress? Thanks.
Yeah, Jeff, thank you for the question. From the baseline objectives, again, we completed the first half of Priority 1. We'll realize the second half of Priority 1 on Splashdown Day. Priorities 2 and 4, which are demonstrate the vehicle in the flight environment, and then what we call the bonus objectives associated with science, technology, and just outreach. There's 124 objectives in combination there. We are over 30% complete in those objectives. We're about 37.5% complete, or 37.5% in progress. And that is because we continue to take data, and we're going to continue to take data until we get up to the return trajectory correction maneuver number 5, just shy of 2 days from now. So, we are on the 8th and 9th out of 10 data takes on those for things like optical navigation data takes and Star Tracker thermal data takes and a whole host of other objectives. And then some of those we will not realize, the remainder we will not realize until entry, descent, landing, and splashdown. And then there's 1 or 2 that it's really kind of a post-flight thing, like corrosion monitoring on the vehicle. Just the fact that we've splashed down kind of initiates it, but the actual closure of that objective doesn't occur until after the mission, and we remove the witness samples to understand what the saltwater environment did to the vehicle at splashdown. So we continue to make good progress. That's where we're at. It may not sound like we've moved the meter that much since what we had previously talked, but again, we continue to do more and more data takes. We've also added 14 what I'll call new objectives in the course of the mission, and the bulk of those are complete. We're complete through 10 of those, and 4 of those are either through multiple data takes or we've got a couple of them that we have yet to start. So we're kind of above the 124 that we talked prior to the mission. We've added 14 since then, and then Priority 3, we'll realize that one when we splash down and recover the vehicle.
All right, our next question is from David Curley with the Discovery Channel.
Thanks, everybody. In the last briefing, and I'm not sure who was talking about it, was about after recovery of protecting the heat shield. So once it's in the well deck, can you just give me a short explainer of how you're going to isolate the vehicle so that you don't damage the heat shield at that point, so you can get a great data from it? Thank you.
Yeah, David, if Melissa's on, she can answer that one. Otherwise, I'll take a crack at it.
You can go.
Okay. So when the vehicle splashes down, it's buoyant. It sits there in the ocean water. In order to protect it, one of the first things we do is to flood the well deck past the point where if there's any wave action, that it's not, that the heat shield is not going to contact the base of the well deck. Then once the spacecraft is past what they call the stern gate, which is basically the back end of the ship, they close the stern gate, and it basically isolates the ocean and the wave action from the ocean from the well deck itself. So now you literally only have the ship by itself with the water inside of it, with the stern gate closed. And then they position it over what they call a recovery cradle. And the recovery cradle has some rubberized material that is basically conformed to the shape of the base heat shield. And then they basically position the spacecraft over that recovery cradle and then drain the well deck while they're holding it over that position and literally lower it down onto a perfectly conformed cradle base, and then that is how we protect the heat shield.
Our next question is from Marcia Smith with Space Policy Online.
Thanks so much. Mike, could you review again what weather criteria were violated at the original landing sites? Was it wind or sea state or rain, or what exactly was it? And what will the weather be at the point where you are going to splash down? And can you tell us what the coordinates are of the splashdown site, or is 100 miles west of Guadalupe Island the closest you can tell us?
Yeah, Marcia, thank you for the question. The coordinates, we are not at liberty to share that based on guidance we've been given by our U.S. Navy counterparts. That's what I'll say on that one. Judd described the area that we're talking about. In terms of the weather criteria that was violated, we have this cold front moving into the very southern California area, and right where the normal landing site is, it is going to set up and or come through in the same time frame that we're looking to splash down. And closer in the shore, which is some of the what we call the northern weather alternate sites, we are expecting light precipitation. So rain is part of the criteria. We don't want to fly the spacecraft through rain or have descent and splash down through rain. In addition to that, with the cold front moving through, we are going to have an increase in winds, and then the winds are going to whip up the waves. So the wave height that we're allowed to recover is up to 6 feet, but there's also a wave period that is of consideration. The waves are going to get choppier as the wind picks up as the front moves through, and the recovery operation takes several hours. So while the spacecraft could splash down in that area, because the winds are forecast kind of right at the max of what the design limits are, which is at 20 knots. The forecast was around 17 to 20 knots in the planned landing zone, a little bit south of where the rain is forecast. The spacecraft design would probably be okay. The recovery operation may get challenging because of the wave action being kicked up by the winds, and again, it's a multiple hour operation. So there was an uncertainty zone in there for the weather forecast, and we moved south of the uncertainty zone, and that's why we got to where we got. So it was a combination of rain, winds, and wave height.
All right, our next question is from Nadia Drake with Scientific American.
Thank you so much. I think this question is for Mike. You've told us about the issues that you've encountered so far on this flight, including an early problem with the star tracker, the funnies, quote unquote, with the power conditioning and distribution unit, and the Goldstone Deep Space Network going down this past weekend. And I'm curious, what, if anything, would you say is the most significant or the most concerning issue that you've encountered so far? Does anything rise to the top? Thank you.
Thank you for the question, Nadia. The most significant thing I would say is the vehicle is performing as designed, and in spite of some of the challenges that we've seen with some of these latching current limiters on the power conditioning and distribution system, and in spite of some of the glitches that we've seen with radiation hits on some of the equipment, the system design and robustness is handling it just fine. And that is partly because the system's autocorrect but also because we have our operations team that is here in Mission Control that is identifying these and in short order getting the vehicle back to a normal configuration. Of those that we encountered, the one that we don't fully understand are the uncommanded open indications on the latching current limiters, which is part of our power system. That is an anomalous feature, and I think we're up to 17 occurrences of this occurring throughout the course of the mission, plus the 4 feeder current limiters that opened a couple of days ago, all in close proximity that drops some downstream power loads. That is the one thing that the team is really working hard to understand. We have yet to achieve a root cause on that, and the team is going through a series of actions to try to isolate. Is it on the battery-fed part of the power system? Is it on the solar array-fed power side of the power system? Is it on side A of the system? Is it on side B of the system? So they're methodically working through it, and in spite of all that effort, we have yet to clearly identify a root cause. So I hope that answers your question.
Our next question is from Joey Roulette with Reuters.
Hey, thank you. Sorry if I missed this before, but could you, I guess for Mike, could you explain what some of the most important objectives, bonus objectives, are that you guys added during this mission? And also for Mike or anyone else who wants to answer it, just trying to explain, what the importance and or difficulty associated with, meeting this re-entry objective is. I mean, it's obviously different from a spacecraft entering through the atmosphere from LEO, and I guess kind of explain those differences and how different it is coming from the moon instead. Thanks.
Yeah, Joey, thank you for the questions. In terms of the most important bonus objectives, they're all important in their own way. Some of them have helped us understand where there's margin in terms of either the coolant system or the thermal system. Some of them have helped us understand kind of alternate means of attitude control and potentially some propellant savings measures that could be implemented on future flights, and then also to help us understand kind of some what ifs if we were to see those on future flights, like a gaseous nitrogen leak on the Orion main engine. What that would mean to loss of mission success. Should we see a valve that doesn't indicate properly, how we might find an alternative means of doing that. So those things are a high bar to demonstrate on the ground, because you need a lot of systems. You need the controllers, the effectors, you need the propellant, you need the nitrogen, you need the proper thermal conditions to set all these things up. It is easier to demonstrate those things on the flight vehicle in order to characterize and buy down and understand your margins, but also what your likelihood on future missions of having a loss of mission or a loss of vehicle are. And the team has done a fantastic job of identifying where there is extra time, extra propellant to buy down these risks moving forward. So I wouldn't say one is any more important than the other. Now, obviously, if what we demonstrated on this flight helps save the next mission, that becomes very important. We may never see some of these things on future missions. We may never need that extra propellant. We may never need the indication on the Orion main engine, because the indicators may work just fine, but we're testing the system and we're understanding and characterizing it. In terms of your second question on the importance of meeting the reentry objective, it is our priority one objective, and it is our priority one objective for a reason. There is no arc-jet or aerothermal facility here on Earth capable of replicating hypersonic reentry with a heat shield of this size, and it is a brand new heat shield design, and this block Avco design, and it is a safety critical piece of equipment. It is designed to protect the spacecraft and the passengers, the astronauts on board, so the heat shield needs to work. And we can buy down some of that risk on the ground, but in terms of coming back at Mach 32, and in terms of taking out the amount of heat and approaching temperatures of 5,000 degrees Fahrenheit for as long as we need in order to bring a 20,000-pound spacecraft with astronauts on board is not something we can do on the ground. So that's why it's our priority one objective.
All right. And those are all of the questions that I'm seeing for today. So thank you to everyone who joined and asked questions. I think we all know what's coming up next, and that is Splashdown on Sunday, December 11th. Our live coverage will begin at 11 a.m. Eastern Time, 10 a.m. Central, and we expect Splashdown around 12:40 p.m. Eastern. Following Splashdown, we will have a briefing at about no earlier than 3:30 p.m. Eastern. But we just want to thank you again for joining us for Orion's incredible journey around the moon and its journey back to home so far. But with that, that'll wrap it up for us today here at Johnson Space Center. Go Artemis!
Well, in my left hand I have a